Hello, everyone, and welcome back to your channel of Math Made Easy. We are in our second session of Trig. So last time we were looking at the 6 trigonometric functions that we discussed, and we said the meaning of each one, why it was called like that, and how do we measure them. And today we are going to discuss, or not discuss, to show what if the angle we are checking is like greater than 90 degrees. So if it's an obtuse angle or if it's any angle from 0 to 360, and for that reason, usually we plot what we call a unit circle. Unit meaning its radius is 1, and you will see why we picked one specifically. So let's draw the x and the y axes. So here is the x-axis, okay? And here's the y-axis. And oops, oops. The x and the y divide the circle into 4 quarters, right? We call each one a quadrant. So quadrant 1, quadrant 2, or you can write it double I for this Latin numerals, Q3 and Q4. It doesn't matter. Before we start, we are always going to draw our angle from the center to the radius. Okay, so if I want to draw an angle, say, of 20 degrees or something, it doesn't matter the measure, I would draw it like that. If I'm in the second quadrant, I'm going to draw an angle like that. So let's call that theta 1 because it's in the first quadrant, theta 2. Notice in the third quadrant, I always go from the center, okay? So that would be, oops. Any angle, I'm not making them equal, it doesn't matter. So this is theta 3. And in the fourth quadrant, let's make it bigger, because really we are not worried about the measurements. What you need to know is that the x is positive to the right of the y-axis and negative to its left. Of course, you know that. I'm just, reiterating stuff that you already know. And the y is positive above the x-axis and negative below it. Okay? Now, if I want to draw a right triangle, so I will complete that as a right triangle. Here's another right triangle. Hopefully, it's not 90 degrees, but we'll assume I draw it properly, and this one. So in these 4 triangles, I can measure the sine, the cosine, the tan, the secant, everything for the triangle, making sure that the x on the right-hand side, as we said, is positive, and on the left-hand side is negative. The y above is positive, below is negative. What we are going to agree upon is the following. If I want to measure an angle, say, of 140 degrees, I'm going to say no. I'm going to say that if this is 140, I say no. I'm going to use it as 40. And you say, but they are not the same. I say, yeah. But bear with me for a second, and you will see why it makes perfect sense when we do it like that. Okay, so if I'm in the first quadrant, the sine is opposite over hypotenuse. The cosine is adjacent over hypotenuse. And since both the opposite and the adjacent are positive because I am in the first quadrant, and the tangent is sine over cosine, and since both are positive, all the 3 important or primary functions are positive. So I'm going to write A for all. When we move to the second quadrant, from now on, I want you to think from not universally, but because we are measuring the angles from the x-axis, think of the x as cosine and the y as sine. That would make life easy for you. Why? Because if I'm measuring the angle from the x-axis, the opposite is always going to be the vertical, which is y, and the adjacent is always going to be the x. You need to know, according to the Pythagorean theorem, we know that x squared plus y squared equals, this is the radius r squared, right? So r really is the square root of x squared plus y squared, so it's always positive. So this is positive, this is positive, this is positive, and that's positive. So when I calculate the sine or the cosine, I'm only interested about either the opposite or the adjacent, because the hypotenuse is always positive, right? Okay, so when I look here, I see that the adjacent, which is the cosine, is negative, but the opposite, which is the sine, is positive, and the tangent is sine over cosine. If one is positive, the other is negative, you end up with negative. So only the sine is positive in the second quadrant. Okay, what about the third? Cosine is negative, sine is negative. So both of them are negative, but when you divide the negative by a negative, you get the tangent to be positive. So here only the tangent is positive. When you go to the fourth, x is cosine, positive. Y is sine, negative. Negative over positive is negative, so the tangent is also negative. Only the cosine is positive. Okay. Now, as an absolute value, if I make theta 1 equals theta 2 equals theta 3 equals theta 4, they will have the same sine, the same cosine, the same tangent. Okay? Meaning, use your calculator. But before I use my calculator, I have to make sure that my mode is degrees. Here it's radians, so I will change it into degrees. And then let's pick an angle of 30. I know that sine 30 is 1/2. So I say sine 30, I get 1/2. What if I take sine 150? I say no, instead of saying 150, and since this whole angle is 180, then theta 2 would be 30. So let's say sine 150. The sine is positive, so I should get 0.5 also. Absolutely. If I go to this angle theta 3, which is 90 plus 90, 180 plus 30, 210, I should get 0.5. But guess what? Negative 0.5. Why? Because in the third quadrant, only the tangent, of course, and the cotangent, but we are talking about the three. Let's write the others. If the sine is positive, then the cosecant is also positive. If the tan is positive, then the cotan is positive. If the cosine is positive, then the secant is positive, right? So there are 2 positive in each, and all 6 are positive here. So if we do sine 210, I should get negative 0.5, and sure enough, you get negative 0.5. If I go all the way 360 minus 30, because this is 30, meaning sine 330, I also should get negative, because the sign here is negative, but I should get negative 0.5. And you can see that it's so easy now. If you know the angles, of course, you don't know, for example, what is the sine of 12, but if you know the angles 30, 45, 60, it doesn't matter in which quadrant they are, because their absolute value is the same. If it's cosine, then it's positive when the x is positive, first and fourth. If it's sine, sine is positive when the y is positive, first and second. When it's tangent, it's positive when the sine of sine, S-I-G-N, of sine and cosine is the same. Either both are positive, like in the first, or both are negative, like in the third. Very simple now, right? So I don't care what you tell me, what angle you give me. I will find out in which quadrant it is. This 0 or 360 if you take a whole turn, or any multiple of 360s. This is 90, this is 180, this is 270. So if you give me an angle, I will find out where it is. If you say tangent, and then you can, even if you make an angle more than 360, suppose just for the sake of argument, you tell me the angle is 585 degrees. What is its tangent? I would say, okay, I will take how many 360s exist here. So you can, even if you don't know and you have a very large number, divide it by 360. So let's add 1080, meaning 3 turns. So I want to show you something. If I add 1080, meaning I get 1665, right? And they ask you, what is the tangent of 1665 degrees? You say, why are you giving me that? I'm going to see how many 360s exist. So 1665 divided by 360 is 4 point something. So I'm going to subtract 4 from that to make it a number between 0 and 1, and then multiply back by 360. I get 225. So this is the same as the angle of tan 225. And then you say 225 is between this and that. So we are in the third, so the tangent is positive. 225 minus 80 is 45. So this angle is 45. I know that the tan of 45 is 1. So the answer is 1. It's that simple. Okay? One last thing. Suppose, so we cover this material altogether. Suppose I say sine of negative 660 degrees. You say, oh my God, negative? Yeah, negative meaning you are rotating clockwise, not counterclockwise, but it doesn't matter. Okay, I would say how many 360s are here? Just one, right? But if I add 360 to that, I'm still negative. So when you divide negative 660 by 360, you get negative 1 point something, negative 1.8. So you'd say, no, I'm going to add twice 360. Why? Because if I add once, I will get still a negative number. So you can say negative 660 plus 2 times 360 to make it positive. And that would be the same as sine of 60. 60 is in the first quadrant, so everything including sine, cosine, tangent is positive, and sine 60 from the table we produced last time is root 3 over 2. So whether we give you an angle between 0 and 360 above 360 or a negative angle, you can always find if the number you end up with is like 30, 45, or 60. If not, then use your calculator. I can say sine negative 660, and I get this number, which is root 3 over 2. Okay, so if you multiply it, if you square it, it would be 3/4 or 0.75. Yeah, because root 3 over 2, when you square it, you get 3 over 4. Same thing, we did the tan, right? Did we do the tan? No. So let's come here. Oops. Let's come here and say tan 1665, and you get 1. Exact. So we are done with that. Hopefully it wasn't that bad. And the only thing I didn't tell you is that when you do a unit, if you do a unit circle, meaning if the hypotenuse is 1 and the sine is opposite over hypotenuse, then the vertical lines will always be sine theta and the horizontal would be cosine theta. Do you see that? Because the cosine is adjacent over hypotenuse and the sine is opposite over hypotenuse. But if the hypotenuse is 1, then the opposite is sine, and the adjacent is cosine. And that's why the sign is negative, as we said, in the third and fourth, because the opposite is going below the x-axis. And the adjacent in the second and third is to the left. So that's why we get negative cosine in the second quadrant and the third quadrant. Finally, what I want to do here before we go further is to say, okay, if you draw any circle, I want to introduce the radian measurement of angles, okay? You must have heard the term radians, right? What does that mean? Okay. Just to be, I don't know why the vertical line always, oh, there was something here probably. Okay, it doesn't. Okay, so here's the x, here's the y, quadrant 1, 2, 3, 4. Suppose I ask you to show me a distance, a curved distance on the perimeter, something around this point, such that that distance, I know it's curved. It's not, but I didn't draw it properly, of course. If this is R and this is R, I want this distance also to be R. Okay? So this angle right here would be called 1 radian. So a radian angle is an angle that has as its arc equal to its radius, to the radius of the circle. Now, if I take this R and make it again here, and then again, and then again, and then again, I would reach the 180, not exactly in 3 radians, you guessed it, 3.1415. Yeah, on March 14th, I will ask you how many digits of the pi you know. But regardless, so if this is 0, that is pi. That's where the number 3.14 comes from. It's the number of radians in a straight line or in half a circle. A radian here, of course, if you divide 180 by pi, you won't get exactly 60, you will get 57 something. So 180 divided by pi. So this is the angle in radians that is, the angle in degrees that is equivalent to 1 radian. And that's why we say the whole circle, the perimeter of the whole circle is 2 pi r. Because this is r, this is r, this is r, this is pi r's. How many r's? Pi of them, slightly more than 3. So pi r and pi r is 2 pi r. Okay? So now if you are given an angle in degrees or radian, it's so easy to convert between them, right? I can do a small table here, very small table, like I say, how to go from one measurement to the other, right? So if you are given if I say degree, radian, degree, radian, of course, if I'm in degree, I'm not going to convert to a degree, or if I am in radian, I don't convert to radian. I'm already there. But if I give you an angle in degree and you want it in radians, notice that the 180 degrees is equivalent to pi. So if the angle is 180, I want it to be pi. So I'm going to multiply by pi and divide by 180, right? So the 180s cancel and I end up with pi. So whatever I have, multiply by pi and divide by 180. And of course, if you have the angle in radian and you want it in degree, you reverse or you divide by that. So you multiply by 180 over pi. Very simple. So if I have an angle of 90 degrees, I multiply by pi, 90 pi, divide by 180. 90 over 180 is 1/2, so you get pi over 2. Here we know it's pi. Here it's 3 pi over 2. And here it's 2 pi, 0 or 2 pi. Also, if I'm given any angle like 60 degrees, 60 over 180 is 1/3 times pi is pi over 3, 45. 180 divided by 4 is 45. So 45 is a quarter of 180. So when you transform it into radian, it becomes pi over 4, and so on and so forth. So the conversion is very simple, right? So even if I tell you, what is the cosine of 5 pi over 6? And you say, what? I don't know. Cosine of 5 pi over 6. You say, okay, this is equivalent or equivalent to cosine of 5 pi over 6. I want it in degrees because I know it in degrees, 180 over pi. The pi's cancel. 180 over 6 is 30. 30 times 5 is 150. So this is cosine 150. 150 meaning between 90 and 180, I am in the second quadrant, so the cosine is negative, I would write negative, right? And 150 is the same as 30, so minus or negative cosine 30. Cosine 30 is root 3 over 2, so the answer is negative root 3 over 2. Or if you are allowed to use a calculator, just make sure you are in radian mode. This is a very confusing thing for students if they don't change it. And say cosine 5 pi over 6. And you get again negative root 3 over 2. We saw that this is root 3 over 2 before. I hope this was enough. I mean, it's concise in one sheet. I hope you got everything clear. If there is anything ambiguous or you think I did an error or I didn't explain anything properly, please write a comment and I will get back to you as soon as possible. Otherwise, I wish you all the best of your times and hope to see you soon.